Okay, in this video I'm going to go over the solution to Chapter 4 homework, and we'll start off with number 4. Remember, problems 1, 2, and 3 are due to be handed in this week. So I'm not going to give you those solutions yet. I'll do those at the beginning of class. But before I start going over the solutions, I just want to call your attention to the table, the phase diagram relationship table, because there's an important piece on this table that I forgot to mention in class today, and I want to make sure that you know about it. And it's on the second page. So here's our first page. So on the second page of this table, when we're looking at our unit weights, and there's actually one unit weight on the first page, the unit weight of water is on the first page at the bottom, but then there's 3 more units weights here. And when we take a look at that phase diagram worksheet, we have the gamma of air, gamma water, gamma solids, and gamma total. Gamma of air does not appear on this table because we just use 0. We're talking about that for this class. But there is something that appears on this table that does not appear on the phase diagram, and that's this gamma D. And gamma D stands for dry unit weight. And it's the weight of solid material divided by the volume of the total soil sample. So when you look at your gammas, for instance, gamma of solids is weight of solids over volumes of solids. Gamma total is total weight over total volume. You can flip back here to gamma water. Gamma water is weight of water over volume of water. But gamma D is the weight of solids over the total volume. So it's just a definition at that information to calculate. And so we're going to need to know that, because that's going to make a difference on some of our homework problems. So I apologize for not covering that exactly in class. It is here on your handout, but you would have to find it and note that difference. So let's take a look at this homework problem and see if we need to know that. So we've got a saturated soil sample. So we can say that saturation ratio is 1. It's got a void volume of 0.38 feet cubed. So here's my void volume. And it does have that dry unit weight of 100 pounds per cubic foot. And that's the gamma D. Remember, when we take something and we dry it out, we call that the weight of the solids if we have the weight. But when we have the unit weight, we distinguish between a dry unit weight and a solid unit weight, because they are defined differently, and you can look back to the table to convince yourself of that. The dry unit weight is that weight of the solids over the total volume, and the solid unit weight is weight of the solids over the volume of the solids. So they are defined a little differently. Okay, so we're going to complete a phase diagram worksheet, solve for the water content. Remember, that's our little w. Water content. Void ratio is my E of this soil sample. And we're also going to assume the total volume of the soil sample is 1 cubic foot. So my V is equal to 1 cubic foot. All right, I know that's kind of small, but let's get to our phase diagram here, and we'll start putting some values in. So I've got a phase diagram here. This is for, slide that up, homework problem number 4. And then I'm going to put my steps on this page here, right next to it. Try to get these kind of back and forth so you can see it. Okay, so my first 3 steps are just the things that I know for any problem. So I'm just going to put them right here, 1, 2, and 3. And they are that the weight of air is 0, that gamma air is 0, and that gamma water is 62.4 pounds per cubic foot. Okay, and then I'll just move those over to here and put them in. Weight of air is 0, gamma air is 0, and gamma water is 62.4. Okay, that's always the place I'm going to start filling in my phase diagram worksheet and my first steps. Okay, from here, you might have deviated from me. That's totally fine. Just make sure that you have the right values with the right variables, I'm not going to check on tests or exams for these numbers. I mean, that doesn't really matter that much. It does let me know what you were thinking, but there's, like I said, there's many ways to do it. What I did fourth was I used that information that the total volume was 1 cubic foot, so I put that in for my total volume here, 1, and then I duplicated it here. So that was essentially my fourth and fifth step. And you can write those together or something, or just dupe for duplicate. All right, then my next thing I did was that I used that gamma D. Remember, it said that that dry unit weight was 100 pounds per cubic foot. Now, there's nowhere to put that information directly into my phase diagram. I don't have a gamma D in here. But if I look at that relationship from the table, grab that table here, I do know that gamma D is equal to the weight of the solids over the total volume. So I know gamma D and I know the total volume, so I can find the weight of the solids. So let's go ahead and do that algebra. So gamma D equals weight of the solids over total volume. So I'm going to write that down. Gamma D equals weight of the solids over the total volume. Okay, I know this, gamma D, and I know this, V. I want to solve for this. So I need to, that almost looks like volume of the void since I put a check there. I don't want that to look like volume of the voids. So in order to solve for this weight of the solids, I'm going to multiply both sides by the volume, by V over 1. That's going to let this volume cancel out, and I'll be left with the weight of the solids is equal to the volume times gamma D. And if we take a look, remember our overall equation here, that weight is equal to volume times gamma. So that weight would be equal to volume times gamma, and that seems to make sense. So those units are going to work out okay. So let's put our values in here. Remember, our volume is just 1 cubic foot, and my gamma D is 100 pounds per cubic foot. So my cubic feet are going to cancel out, and I'm just going to wind up with 100 pounds is my weight of the solids. So that one I can put in here, and so that's going to be number 6. Oops, I can leave that there. I've got this all organized. Okay, so my weight of the solids is going to be 100. All right, next I can use my information about my saturation ratio. Okay, I said that S sub R, it's 100%, it's 100% saturated, it's a saturated sample. So that ratio is 1 as a decimal, right? 100% is the same as 1. And when I know that, I can remember from my table, I should just leave this on the other side, that degree of saturation is going to equal to the volume of water over the volume of the voids. So I'll write that down here. SR equals VW over VV. If SR is equal to 1, that just means VW has to equal VV. Okay, so in this case, and we talked about that a little bit in class, that if it's totally saturated, every void. So that's how that's going to work out. So when we take a look up here, we know those two are going to be equal to each other. And that's going to tell us that we don't know what either of those values are yet, but it does tell us that the volume of the air is going to be 0. So we can use that for number 7. Again, if you didn't do it in this order, that's fine. And remember, we've got to have that whole first row to be 0 for a fully saturated soil. So that's looking good. Okay, so let's figure out what we can know now. Let's see, we can figure out that this volume, let's try to figure out the volume of the water. So if we know, well actually no, let's do the volume of the voids because that was actually given to us. The volume of the voids was given to us as 0.0 0.38 cubic feet. And so you might have had that as an earlier step. That's fine. But here it is, number 8, and that's 0.38. And now that we know that, now we'll figure out the volume of the solids. Because we know that plus something is going to have to equal 1. So that'll be our step 9. And we'll just say volume of the voids plus volume of the solids has to equal 1. I know my volume of the voids is 0.38 plus something is going to equal 1. So I'm just going to take 1 and subtract 0.38. And when I do that, I get that the volume of the solids is equal to 0.62. Okay, so I can put that here. That'll be my number 9, 0.62. And then I can just duplicate that over for number 10. So I could even just say duplicate 9. Slide that up a little bit so you can see. I'm trying to keep it so you can see both of these at the same time, but it doesn't give me a lot of space to show my steps. All right, so I've got lot filled in here. Well, now I think I'm going to do that volume of the water since I can use that additive relationship. And also we said that the volume of the water is equal to the volume of the voids because it is fully saturated, so I'll just do that for number 11. Volume of the voids equals volume of the water, and that was given anyway. So it's just 0.38 feet cubed. And like I said, you can certainly have done these in different order. Okay, what can I find next? I look at this and I can see that I know a volume and I know a gamma here, so I can do W. I can just go straight up. I'm actually going to slide this paper over a little bit, so I'm going to make that part go away and put up at the top number 12. And number 12 is going to be the weight of the water is going to equal the volume of the water times the gamma of the water. And in this case, I have 0.38 cubic feet for the volume and 62.4, slide over a little bit more, put that in, pounds per feet cubed for that unit weight of water. And when I do that out, I'll do it here, 0.38 times 62.4, I get 23.712, but remember we're just going to do one decimal place for weight. So just 23.7, and my feet cubed cancel, so I wind up with pounds. So I'll put that in here for number 12. It's 23.7. Okay, I can see, I just happen to notice that this is going to have an additive relationship, so I'm going to do that next. Maybe you wanted to do this one next. Like I said, it doesn't matter the way you do your steps, just as long as you keep a note of them. But I'm going to do this one next. I'm going to add them up to get my total weight. Because I know my total weight, I'm going to find it just by adding up that column. Weight of the air plus weight of the water plus weight of the solids. Weight of the air is always 0, so it's really just adding these two together. I can do that pretty well. That's just that 123.7. So that's equal to 123.7 pounds. And then I'm going to go ahead and solve for my gamma solids here. I'll just do that next. You could also solve for the gamma total either way, but I see this, so I'm going to do that. I remember I use my top here that volume of the solids times gamma of the solids is going to equal to the weight of the solids. But the thing I'm looking for here is gamma solids. So I'm going to divide both sides by the volume of the solids. Those will cancel out. I'll wind up with gamma solids equals weight of solids divided by volume of solids. So it's 100 pounds divided by 0.62 cubic feet. And when I do that math, 100 divided by 0.62, I get 161, etc., but we're just taking that to one decimal place, so 161.3. 161.3 and it's pounds per cubic foot. So I'll put that over here. That's my solids, 161.3. And I know it's really tempting for 15. You just think, oh yeah, I'll just add this column up. But remember, it's got that box around it. These unit weights, they're kind of funky. They don't have that same additive relationship. So you can't just do that. So in order to find my number 15 here, I'm going to have to use a similar process I used to find 14. I'm going to have to say that my total volume times my total gamma equals my total weight. And then to find my gamma, I'm going to have to take my weight and divide it by my volume. But that's some pretty easy math here because it's just a 1. So 123.7 divided by 1 is just going to be 123.7 pounds per cubic feet. So that's the way to handle the homework problem 4. So now I've got my list of steps and my phase diagram worksheet. I wish I could show it all at the same time, but it doesn't quite fit on the page together. But that'll give you an idea of how to handle that gamma dry. Okay, so when you see that gamma dry, when you see something that says dry unit weight, or it might say dry density, remember, you can't just use that it's the gamma solid. You have to come to your phase relationships and look at what that's meaning, and that's the weight of the solids over the total volume, and use that relationship instead of the gamma solid. Those are 2 different values. Okay, that's it for homework 4. I'm going to pause this now and do the next homework problem on another recording.